Right, so let us try to understand one of the important concept in AWS, that is of load balancers, right? So as the word sounds, load balancer meaning balancing the load, right? And in terms of cloud computing, what actually is the load? It can be multiple factors, right? And like whether the user is sending the request, whether multiple users are sending request at the same time, whether it is the CPU utilization, or it can be some another factor. So balancing the load is a factor in AWS, right? So that is gonna we are going to learn specific one. Okay. So a load balancer is a service that distributes the incoming traffic, that is the request to your website, across multiple servers. This ensures that no server get overwhelmed, improving the reliability and performance. Okay. So let's consider that you have an EC2 instance, and there you have hosted on website. Okay, and there are multiple users who are trying to access the website. Now what will happen, it will work till a while, but when it will reach its threshold, at that time things will be bad. What will actually happen is like either your EC2 server will be unresponsive, or either your site can go down, right? Or either both can happen at the same time. So in order to avoid such scenario, we make use of load balancer, where actually what it does, whenever it receives a n number of requests, and whether when it is about to reach its threshold, it will create another server and will distribute the load uh, same way, so that a single server doesn't carry the heavy load, and it is getting distributed in equal servers, right? That was all about load balancer. Now how does it determines on what basis basically it considers whether I have received reached the threshold or not? So for that specific thing, we have a thing called health check. So health check is a feature in AWS load balancer that actually checks the status of your server. So basically it pings your server every time whenever a request, and actually it ensures whether the things are working fine. So if a server fails, then the load balancer stops sending the traffic to that server, and it actually redirects the server to the healthy server. Let's take an example, and it will actually become clear for us about health check and load balancer. So if your server crashes or becomes too slow, the load balancer will detect this with the help of health check, and it will avoid to send the traffic to that specific server. And this actually ensures to continue a smoother experience to the users, right? The live example here would be Netflix. Netflix or Hotstar, whenever there is an IPL match or wherever there is a World Cup, at that time multiple users from multiple location are trying to access the same application. Okay, same video. At that time they have something called load balancer, which actually replaces the load into multiple servers, and that is something happening at the back end, and that is how the user won't feel that lag while using the application. Okay, now, how many types of load balancers we have? So basically, balancers are categorized into three classification. First is application load balancer, network load balancer, and third is classical load balancer. Okay. However, classical load balancer is deprecated from AWS. We will be focusing more on application load balancer and network load balancer. But since we are preparing for the examination and we are just trying to go through the concept, we will be covering classical load balancer as well. All right, let us move forward and let us understand about application load balancer. So it is what is the use case for it? It is basically best for HTTP and HTTPS traffic, and it actually works on layer 7 of the OSI model. This is highly flexible and can route traffic based on the content. So basically, you have URLs or headers, for example, slash HTML, slash index.html, slash error.html, right? So based on the path provided, it will redirect the traffic. The example use case, if you have multiple versions of your website like slash login or slash sign up, application load balancer can route your traffic to different server depending on the URL. Okay, so here the load is balanced with the help of the endpoint that we provide. Second is network load balancer. So it is ideal for the people who want less delay. So it is good for the people, those who are doing gaming, right? Where each and every pixel matters, right? So it is ideal for ultra fast, low latency TCP UDP traffic, and it actually works on a fourth layer of the OSI model. Network load balancer is used for the application that actually require high performance for handling multiple or millions of requests per second. The best example here is when you need fast connection with minimum delays, such as gaming servers. It is the best example for it. And real-time transaction for example, Razorpay. Okay. Next is classical load balancer. So this is the older type of load balancer that we have, which can handle both HTTP and HTTPS traffic, like application load balancer, and TCP traffic like NLB. Or but basically the here issue is it will give you few features. But AWS recommend us to use application load balancer or network load balancer for new applications, since classical load balancer is a legacy, okay, and it doesn't support the advanced routing options. That's the reason we are more focusing on application load balancer and networking load balancer. Okay, so let us wrap up the things and let us cover what we learned. So we covered application load balancer, which is good for the web apps with HTTP and HTTPS traffic. Second is network load balancer, which is good for high performance, low latency application. For example, gaming and real time application, or for the services which actually require real-time financial transactions. Third is CLB, classical load balancer. It is older version. It supports basic routing functionality for both HTTP and TCP, but it lacks flexibility, and hence we are proceeding and switching our ways to newer options. Right. That was all about load balancer in AWS. I hope you learned about load balancers in the specific one. So see you in the next one.